going into that, I thought probably I will give you some introduction, because I am sure we have a group, a mixed group, mechanical engineers, electrical engineers, and again metallurgical engineers. So we have a mixed group here. So how much time I have, sir? Computers, silicon age. Now we are in the age of intelligence, artificial intelligence and automation and mechanization. Industry 4.0 says these are the upcoming fields that are going to influence our civilization. So as engineers, as teachers who are making engineers, are engineers who are going to take care of future. So it is always a good idea to understand materials in their right perspective. So if you see these are all basics. First few slides I thought I'll just go with basics. So broadly we can divide materials into three categories: metals, ceramics and polymers. And you all have studied in your first year the properties of each group of materials. What are the properties of metal, what are the application areas, ceramics, metal, and then polymers. Apart from these three groups, we have other groups such as composites, triples. So the optical properties change, the electronic properties change. So all these property variations are purely because of the scale of the materials. See, it is derived from the principles of all the other known subjects: physics, chemistry, nanotechnology, mechanical, electrical. So there is always a great overlap of material science with respect to other engineering fields, and that is the reason why precisely in first year you all made to study some part of materials. Now when we talk about materials, there is something called tetrahedron, performance, processing, properties and structure. So these are the four things that are interconnected. As a human being, as an engineer,
you have iron carbon. This is the standard what we discussed. Iron carbon, some phase is there. Carbon is sitting in some interstitial sites. Okay, iron sites are there. So there are well-defined positions where carbon should sit, where iron should sit. In any crystal structure you take, or if you take copper, nickel, or any BCC structure. So when you add two elements, every element knows where it should sit, right? That's what the crystal structures which we study. But what happens when you have 5 or 6 elements? They get confused. They don't know where I have to sit. This is called a principle of confusion theory. So we should have multi-component system, so that then this crystal structure should be avoided. Amorphous means there is no crystal structure. When to form a crystal structure, it is very difficult. You are giving so many conditions so that it is very difficult for them to form a crystallographic structure. Then amorphous material will form. The amorphous materials have a lot of advantages. Like I will be presenting with time, I will be telling you why amorphous materials are better and all those things. So to form amorphous materials, we should violate Hume-Lethierry rules. We should have large physics. You are coming down to 1100 and change something. So 400 degrees centigrade, you have a lower. You are lowering the melting point, right? By adding just 4% of carbon. Your example in our day-to-day life, which was asked by my friends in various interviews. Can you tell one eutectic? Seawater, sea. Why seawater doesn't freeze at 0 degrees? Actually, water should freeze at 0 degrees, right? This is the interview question. Why seawater doesn't? Temperatures are very, very low. Otherwise, our sea never freezes. Or suppose if you see, but Dal Lake freezes. You see, Dal Lake in winters it will get freezed. Maybe when temperature is 0 degrees or -1 or something like that, Dal Lake freeze. But sea will never freeze. So this is the eutectic system. So what I want to tell you is, when you have a very high negative heat of mixing, you will find eutectics. And eutectics are the best systems where you can form amorphous phases. Amorphous phase. So we are discussing in point of how to make a nanomaterial and all those things. So making an initial amorphous material and then trying to crystallize it to a nanomaterial has many advantages, which I'll show you in subsequent this thing. So these are areas of research where you will come across in future. So I want to just give a feel about how, just a brief introduction about or a feel about these systems. Next. So this is so now we are telling about rapid solidification. So how do we make it in a vacuum chamber? See, one important thing you should remember when you are melting an alloy is oxygen. When you are melting in open environment, you will have oxygen everywhere. So any material or any metals, when they are exposed to oxygen, they will become oxides. So they will become, they will lose its properties. So first thing which you have to know when handling or working in a lab, when you want to melt these alloys or this thing, you should remember that it has to be done in vacuum conditions or inert conditions. That is in argon environment or nitrogen environment, like that. So we generally do it in vacuum. So we are in this method, what I am telling is a vacuum melt spinning unit. The name itself is having vacuum. So we are melting this alloy with the use of a induction coil. That's a water-cooled induction coil. The alloy will melt and it will be ejected into a rotating copper wheel. So now I tell you how 1 million degrees per second cooling rate is coming. Generally, most alloys melting point will be typically 1000 plus minus something. So let us assume 1000, that is 10 power 3 degrees. Within 1 millisecond, it gets cooled to solid. From liquid to solid, it is coming in fraction of a second, that is less than 1 millisecond. Now what is the cooling rate? 10 power 3 divided by 10 power minus 3. So it is 10 power 6. That is 1 million degrees per second. So we are by this method we are getting very high cooling rates, which we cannot get in a normal casting method. You understood this thing? But there are some limitations. You will get very small sample. You cannot get big. But this is for a basic research and all. Now equipments are there where you can do very large quantities also. I'll show you these things. Next. You can see the down image is a magnified image of that region where there is a quartz nozzle. In the quartz nozzle we are melting the alloy and ejecting it onto this rotating copper wheel. So I have taken a magnified view and showing that the liquid metal is coming and it is getting solidified on the copper wheel. So you need a very high speed camera. Normal cameras will not work because I told you it is in a fraction of a second. So you need very high frame rates camera. Next, I'll show you some things which we have published. So now there are two methods in melt spinning. One is a conventional melt spinning, another is a planar flow melt spinning. Simple difference between melt spinning and in melt spinning you will get some flakes, some ribbons which are discontinuous. But they are amorphous. They will be mostly amorphous. But in planar flow melt spinning, you will get very good tapes, very good like ribbons. We call them ribbons. Like your normal ribbon is there, so they will be continuous. So these metals are like ribbons. You understood the beauty of that. So when you have a metal, I can tell you one thing. So actually, to tell you why we are doing all these things. Now, have you come across any transformers? You know what is a transformer material? What is the transformer material made of? Transformer core which is made up of? CRGO. CRGO steel. What is CRGO? That is what is that? It is an iron silicon alloy. Basically, it's an iron silicon alloy. It is grain oriented in one direction. The direction is also on the easy axis of magnetization, like that. Okay. So now people have come across. Have you come across? Just go around somewhere and see. Now there are no CRGO transformers. Now what transformers are coming in the market are in many places you can see. It will be written amorphous. You must have seen that. Earlier it was a very rare thing, but now many places you are seeing they write amorphous. that amorphous will be having this material, this metallic ribbons. And I was lucky enough to go to Vijay Electricals in Hyderabad actually. See, this amorphous transformers are made in Japan. Okay, initially they are made in Japan, and we buy that material and all. Till date in India, nobody is making that material. Vijay Electricals has tried to make it. Actually, we associated with them, and they don't even show you that this equipment what I showed you. They have very big equipment to that. They do tons of this thing, but they don't show this. The equipment and all, but they were doing this assembly and all, so we have like paper, how in printing press, how the paper comes, a long reel of paper gets printed or rolled and all those things. Same way, a metallic ribbon will be rolling and it will be made into a transformer, and then it will be supplied. Though with 5 you will get an amorphous, that's also not there, because now people are coming up with high entropy alloys. There also people have 5-6 elements, but there they have all equiatomic. They have all equal. Suppose say 5 by 100, so 20% they'll be having. So, but there they don't form amorphous, or they may form or may not form, but it's not guaranteed. But you have to choose. There are some criteria. Like I was telling you, you need a high negative heat of mixing. It should be a eutectic system. The viscosity of the material should be increased so that it doesn't solidify quickly. So these are some ways by which we tailor make the composition. So making compositions, how to make a composition, how to make an alloy, these are a very big opportunities when you do research, this thing, choosing which element to choose, which elements to be replaced. Suppose you replace, suppose somebody says copper is very costly, I want to replace with some other element. So now instead of doing this experiment, now people are doing with computational analysis also, thermodynamic calculations also. So these are all opportunities where we can, instead of doing experiments, we can do thermodynamic calculations on the computer and then actually make the alloy. So these are all opportunities I want to highlight upon. Next. So like I was telling you, this is one high-speed imaging which we have done. We really bought a very high-speed camera because the experiment is completed in 1 millisecond. So before that, if you want 100 or 200 frames, so you should have a very high-speed camera. So, and we have studied that how when we process at different conditions, what is actually happening, and when we get good quality ribbons. There was a study which we have done and we have published. So just to tell you that I'm just sharing some this thing so that you can get some interest or something, not that. But these things can be done. We have found that when you increase the pressure, or when you are increasing the wheel speed, and when you are increasing the gap, what will happen? All these things we have published. So it's not that important. Okay, next. And also when you have different temperatures, how the quality of the ribbon. We have found that when we are going for very high temperature, there is some porosity that is formed and all those things. So the quality actually depends on this. So this is also not that great. But we have published. I just want to show that. Next, can you go? Now here you can see. I was telling you. See, we started with an amorphous material, but our intention was to get a nano material. 50 times per second to switch over. For a crystalline material is very difficult because you have a large grain, and that grain to move is not that easy. But what about an amorphous material? Amorphous material, there is no grain. There is no grain boundary. So it can easily switch over. They are called magnetic domains. We have not shown the magnetic domains. Magnetic domains is something like an imaginary, like a North Pole, South Pole, like it. Magnetic materials as domain. Now in an amorphous material, because there is no grains, you can see the bigger hysteresis loop. As per in the bigger one, its core loss is 0.3 watt per kg. So from 1 watt to 0.3, 1/3 it has reduced, amorphous material. Now if you have a nanocrystalline material, okay, nanocrystalline material, again you can say that now there are more grains or grain boundaries. But people have found when the domain is still lower than your nanocrystalline material. So again the losses will be less. There is one theory like you must have come across inverse Hall-Petch relationship. See, what does inverse Hall-Petch relationship says? The strength will keep increase as your grain size is coming down. Okay, but again after some time again there is a change or something like that. That's what inverse Hall-Petch relationship. Similar to like that, when the nanomaterial is again in 20 nanometers, that range, again you will have losses very less. If you see the another smaller loop, this one, this very small thin loop, there the losses are 0.03 watt per kg. That is another one order of magnitude it has reduced. So this is one example. What I can tell you is a nanomaterial. A nanomaterial is having 10 times less loss than a crystalline material. Same composition when you are having a nanomaterial, your losses are reduced. If your losses are reduced, how much energy is saved? I given one talk in this exclusively for this. Then when I was reading out, I was seeing a lot of energy that is generated is lost during transmission. Mostly at the transformers and all those things. That is why now people are switching out to amorphous and then to nanocrystalline. Nanocrystalline is next generation of amorphous. So this is a simple example I want to tell you that how a nanocrystalline material is better than your crystalline material. So, can you now understand what is a crystalline material, nanocrystalline material and an amorphous material? Probably you must have got some basic idea with this. So, this is one example. Next. Okay, this is one basic research we have done. Now, to get an amorphous material, you have to, this is all again your subject. You know what is a TTT curve? Time temperature transformation curve or cooling curves. We call it as a cooling curve. What is cooling curve? When from 1000 degrees to room temperature, how it is?
Indian values where we are going to be concentrated. So here car landing in general, that is a normal practice to provide car landing in any meetings, public meetings or any functions. So car landing means there are two reasons, that means you can able to get two reasons behind that. Why you are going to far? Is it audible clearly to all of you? Yes. Okay. So a garlanding, namaste is one of the welcome note, and another one is to be your garlanding with some chief guest or whatever the guest may be. You may have two reasons of garlanding. One is to be, it shows us the happiness to the respect to invited guest. Number two is to be, it is a form of publicity or publicly acknowledging the guest's importance. దండ ఎందుకు వేస్తారు అంటే గౌరవ సూచనగా వేస్తారనే విషయం తెలుసు, కానీ దాన్ని ఎనాలిసిస్ పరంగా పోతూ ఉంటే ఒకటి ఏంటంటే రెండు కారణాలు దే ఆర్ గోయింగ్ టు సీ ఇట్ ఓవర్ హియర్. వన్ ఈజ్ టు బి షో కాజెస్ వన్స్ హ్యాపీనెస్ ఎట్ రిసీవింగ్ ఏ పర్టికులర్ గెస్ట్. And another one is to be a form of publicly acknowledging the guest importance, the importance of the guest, and for the happiness of the guest. And the significance of the colors of national flag. We'll class la vinoddu. Please be free, feel, and if you have interest at any point, good. At any point, please let me know so that I have to know the knowledge from your side also. Only I got only little fraction of knowledge of the human values. But you may have more than that. So the flag significance of Indian flag is to be color significances. First color, saffron, courage and sacrifice. And that's why I have prepared the PPTs, not boring PPTs. చూడాలనిపించే PPTs మాత్రమే పెట్టాను. So courage and sacrifice. And white stands for peace and truth. Green for faith and chivalry. And the blue represents the color of sky and the ocean. That 24 spokes నాకు నిజంగా తెలియదు. ఇప్పటి వరకు నాకు ఏదో విన్నాను కానీ 24 spokes ఎందుకనేది. clearly they have mentioned here is that 24 spokes of the wheel, Ashok Chakra antam kada, correspond within the 24 hours of the day, implying that there is life in the moment and death in stagnation. Moment ఉన్నప్పుడు we are in life 24 hours మూవ్ అవుతూనే ఉండాలి. Once we have been gone to our rest place, so definitely stagnate. So that indication, what Ashoka Chakra indication is to be that ఉన్న life అంతా కూడా you should be in move on and you have to do your part whatever the extent is possible, and once if you have been stagnation, you cannot do anything further. So that has been shown in our Indian national flag colors. So most of you know about the structure of our India. So at present we are having 28 states. Basically we are having 29 earlier. Recently, because of abolition of Article 320, and Jammu Kashmir has been divided into two territories, so that 9 union territories and 28 states. That is a meal. Before as well as after, how to wash your hands is the biggest Indian value with respect to the dining etiquette. Next, always use our right hand to eat. That is also to be a part of value, whether you are using utensils or your fingers. And the last one and the important one is take off your shoes before entering the house. ఇక్కడ ఒక డౌట్ వచ్చిన తర్వాత ఇంకొకటి ఎక్కడ ఒక పాయింట్ వస్తుంది. ఇది వల్ల ఈ షూస్ చెప్పులు ఉన్నాయి కదా, అవి is it recommendable to open it before our main door of our house? చెప్పండి. నేను ఇప్పుడు వరకు ఏమనుకున్నానంటే డోర్ దగ్గర ఎక్కుతాం కదా, దట్ ఈస్ ద కామన్ నేచర్. కానీ డోర్ ఎదురుగా ఎప్పుడు కూడా వీఆర్ నాట్ సపోజ్ టు టేక్ అప్ అవర్ షూస్ ఆర్ చెప్పల్స్ బిఫోర్ అవర్ మెయిన్ డోర్ ఆఫ్ ద హౌస్ అన్నమాట. ఎప్పుడు కూడా సైడ్కి వచ్చి చేయాలి. నాకు ఈ రోజు తెలిసింది, డెఫినెట్గా ఐఎమ్ గోయింగ్ టు ఇంప్లిమెంట్ ఫ్రమ్ టుడే ఆన్వర్డ్స్. ఓకే, బిఫోర్ డోర్, దట్ మీన్స్ డోర్ ఏరియా, ఏ ఏరియా ఎదురుగా ఆర్ నాట్ సపోజ్ టు take off our shoes. So basic Indian values have been initiated with respect to the Indian culture or Indian that means values, starting with the dining requirements. Dining room, what are the precautions we are going to take it as a, this has to be implemented only in our India. So this has to be spread over to the most of the countries later on. Next we will concentrate on tradition of our Indian tradition. So as far as the basic concepts of Indian values are concerned, we have to know about the structure of the India, constitution of India. Adi meeku could I think maybe in your classes they have been introduced as a I think mandatory courses I think. So communication skills, all these things are going to be incorporated in our national education policy. I think yesterday you may have heard about that class. Literature చూసేంత వరకు God is also part of our Indian values. అది కూడా ఒక పాయింట్ తయారు చేశాను చూద్దాం. సో తల్లిదండ్రులు, పేరెంట్స్, elders are always respectable, and I have been studied different cases. If you are not feeling comfortable with them, you be ideal, but don't delete, that means degrade them before second person. So the elders are always considerable driving force, because without elders, every individual you estimate yourself, definitely without having the driving force of your elders, either your parents or teachers or somebody, some other elders, we are not be on this stage. So the guests are considered to be gods. Guest ante ant easy kaada. Guests are to be likely to be a god and be treated with respect to love, even if foregoing some of the personal pleasures. So you have to consider the elders respectable, lovable, and you should give the respect to the guests as likely to be a god. This also comes under our Indian tradition. అందుకనే మన ఇండియాకి అంత పేరు ఉందనే విషయం came to know after going through different sectors of Indian values and Indian culture. And displaying affection, modesty antam. So these are also comes under the various traditional remarks of our India. So displaying affection, married Hindi couple do not have general topics what are going to be there. Chautunta automatic arthayundi. These things, affection, married Hindu couple do not have hold hands or kiss in public. అవి మనకి చాలా సిల్లీగా అనిపించటంలా. Can you believe it or not, you go through the websites of different human values with respect to the Indian tradition. These points have to be deliberately, they have been
50 minutes, how we plan and how we are doing it. What are the differences between our country and advanced countries like US and Europe? How many people have gone through MIT website? What is MIT? Massachusetts Institute of Technology. How many people have gone through the website? Please raise your hands. None. One. Good. Very few. Teachers are also only one. Ashok only raises a hand. See, please note down if you have a mobile, open it, please. Text it yourself. OCW, MIT.edu. OCW, MIT.edu. Please go through that. It's a world ranked #1 university where you can download any of your material. We have how many states in our country? Anybody? How many states? 29. Good. Oh, unique answer. Thank you. Right. How many languages in our country? Major languages. Maybe Hindi speaking states are 5 or 6. Telugu, Kannada, Tamil, Malayalam. And 22 languages. Mostly, right. Say 20 languages. Look at the complexity now. 29 states, 20 languages. This NEP should be implemented. How? That's the biggest challenge in front of us. And 29 states, different chief ministers. Yes or no? Different political drama behind. Yes or no? One person say yes, other person say no. But how to do it? Because state governments have to implement it. Central government cannot do any alone. Look at that. Look at the complexity involved. But still, if you observe, Andhra Pradesh government at school level, they have already implemented. Do you know it? Do you know? Yes or no? Because it is not there in NEP. Just I want to show you because I have taken a snapshot from what is good, what is not good at least. If somebody speaks nonsense, right? So by 2022 actually these are the things to be done. But how many have done? Please read and understand. First point. All school children should come out of rote learning by inculcating skill-based learning styles. What is rote learning? How many people gone through Chaitanya Narayana? Raise your hands. Came from? Please, feel free. I am asking what kind of methods they followed. By hearted, right? Mathematics also by hearted. Am I right or wrong? No. Formulas by hearted or not? That's not nothing but mathematics by hearting. Yes, sir. Then how to do it without by hearting mathematical formulas? There are methods. Unfortunately, the teachers under whom we train, they don't know. I don't want to comment X, Y, Z, but that's the issue, because our teachers never asked us to by heart. Yes. We practiced it. We practiced. It took a lot of time, but we practiced. There is no hurry for us. But for you, it's, everything is hurry. Eating is also hurry, right? That's the difference. Next point, concept-oriented curriculum designed to reduce the burden on the children. That is our teacher's duty. Critical thinking, analysis, discussion, learnings are to be incorporated. What is critical thinking? Any example? Anybody? What is critical thinking for you? Take one example and can you speak out? Any student? Then later, 16 to 18, that is 10 plus 2, intermediate first year, intermediate second year, right? That's the existing system. Look at that. Yes or no? Some of your classmates already joined in IIT Chennai, yes or no? Yes or no? Please inquire with them. Technical institutes started arts courses, science courses. They are giving degrees. And in fact, our university also, recently, higher education chairman has come, and he is also telling us to start science courses. This university should become multidisciplinary university soon. That is there in the minds of administrators, because national education policy is telling that. So, in that sense, you have to understand how we have to think and how we have to transform. Then, the foundational learning curriculums, then preparatory classes, universal access, and multifaceted access. So, AEC-CE means that is a technical CE in the National Education Policy 66-page document. Whatever I could see, because as I said, I cannot by heart. The DCCE is early childhood care and education. Lot of abbreviations are there, so I could write down the 3, 4, 5 pages. All these are abbreviations only in 66 pages of document. No, more than 8 pages. These many pages, all abbreviations. I cannot by heart it. That's the reason I have noted down for the sake of my reference. So early childhood care and education, ECCE. So that is the title they have followed, and then accordingly they have given outcomes. Then sustainable development goals, SDG. SDG means sustainable development goals. They have fixed it for 21st century children, and accordingly the teaching learning skills, resource sharings, effective governance, and language barriers and common standards. So most of them already I have touched upon. 2 crores of children.
I have established around 20 crores worth of labs. I established a lab. See, that is one thing. If you can see the budget of IIT Hyderabad, if you can compare the IIT Hyderabad budget, the government is giving planned and non-planned grants. Let us say 1,000 crores. But IIT Hyderabad family, they got projects and other schemes. They purchased another 500 crore equipment from the projects. That is very, very important. So you have to get a project. Through that, the UG student will be educated, PG student will get exposure on that. You can complete some PhDs on that, connect to the society, and see that how best it can be useful. And that is one point which I want to emphasize. Anybody want those facilities? Actually, our team planned to visit that laboratory, but because of some other schedules, they have cancelled. But that is where, whenever you have an opportunity, please visit that laboratory, which is near to you, in your doorsteps, hardly 50 kilometers from here. You can see we have facilities of synthesis. We like chemical methods are there, physical methods are there, mechanical methods are there, both top-down approach, bottom-up approaches. And we have characterization techniques like SEM, STM, AFM, etc. And we have fabrication of environment means, I think all of you are studying in the second year level, environment is a mandatory course. Why? Because whatever you can do, it is allowed, but you should not spoil the environment. See, in that place, the materials are playing very, very important. Another is multifunctional. X direction you can keep in one properties, Y direction you can keep another properties, Z direction you can keep another properties. Some intelligent materials, if you can touch, or even if you don't touch, by changing colors, it is giving the different behavior of the property. See, that's what the different materials which we are using. These are the 3-4 slides used to present in every PowerPoint presentation. You can see the nature is giving a lot of branches of trees. Can we make a pipeline like that as a mechanical engineer or a metallurgy engineer? Because that is where the joints, high stress regions. Still, whatever the accidents in process industries are taking place, mainly the leaks due to those joints. Lot of leaks, major accidents are taking place due to the unable to prevent those leaks. See, that is where can we make a pipeline like that? It is a challenging task. If anybody can do that, the people are ready. Lot of industries are looking to solve this. Simple problem is very simple, but the number of branches we have to do. The second one is, if you can consider the shark fish or a submarine, both compare, or even a ship, floating body, submerged body. Submarine is fully submerged, ship is floating. Can we make like a fish? The fish maneuverability. It can move in any direction, the maneuverability. But submarine and ship, can we make such type of degrees of freedom? Can we provide? That is only possible by using the modern materials. You see the topmost, this is the part. A batteries. If anybody can supply a battery for my cell phone, depend upon the usage. If I cannot charge the battery until 1 week, people are ready to purchase. If anybody can give, cost is not at all the criteria. A battery which we are keeping in the cell phone, smartphones, without charging daily basis. See, this is where nowadays nanotechnology, we have a cell, we are doing collaboration with NSTL, proton exchange membrane, that's where the fuel cell in the battery part. Future is, I think all of you know, the electrical vehicles, hydrogen vehicles. That's what I think how many of you are following the news. In India, the first vehicle using by our Honorable Minister Nitin Gadkari ji, the green vehicle is using combined hydrogen, electrical and other combinations other than petrol and diesel. See here, the bird is having this maneuverability also. Wings also can not only lift and drag force, you can control wings also. It will, because of wings, it can land even top of the tree or top of the sea wave or in top of the mountain. But aircraft is not having that option. Now there is a lot of research is going because of this advanced and smart materials, nanomaterials. Now the wings are folding like this to create similar action. You may ask, birds are not carrying any loads, but aircrafts are carrying loads. That is there. Because of that, you are concerned. We are doing huge structures, beams, frames, plates, shells, etc. We are keeping. But other than that, the maneuverability wise, it is a same maneuverability. See, these are some of the challenges to give some what innovation can be done, what invention can be done, how you have to think differently from others. That is where everywhere the research is starting. That is where the research methodology. This is a shell naturally available. Even if you want to break it, it is not that much easy. Available this type, either this form or this form. Let us try to hit it. It won't break. Such a strength material can you give? It is naturally available. As a metallurgist or a mechanical, can you give such type of material? People are ready to use different applications, like armed materials when the enemy is hitting with bombs or bullets, that is where the bulletproof material etc. we can make it, we can utilize. So this is where the vehicles, different vehicles nowadays, the future war is, I think already you are seeing the Ukraine war. The future war is, we can prevent the loss of our security people, army jawans or whatever the cadre. Why? Because earlier the passenger aircraft is we are sending to a border, one pilot, two pilots are required. Even if you want to send an armed vehicle, persons are required. But nowadays we are doing with the drones, wars, most of the wars we are doing with the drone technology. Even doctors are doing surgery without cutting your skin, by doing robo surgeries, by in the tablet, by keeping robo surgeries are doing. That is today the technology is available in the market. See, these are the different vehicles where we can surface, underwater, the different applications people are using. Then let us come to the what are these different materials. First I want to touch about functional graded materials. Depend upon your requirement, depend upon your application, depend upon your functional requirement, we can use the functionally graded materials for different structures. Structure means, let us talk about either a bar or a truss or a beam or a plate or a shell or a column, anything is a structure. This is a column. I think roof is sealed, the horizontal is a beam or a frame, depend upon the load application. If a pitched truss structure. See, like that the different structures which we are using. In that, what are the materials? Shape memory alloys, smart materials, piezoelectric materials, PZTs. In that direction, there is one more important material, that was the functionally graded material. We can tune the material depend upon your the requirement. The applications can be space applications, aircraft, because this is where the different structures we are using. Defense equipments, varieties of applications in medical appliances especially. These are the way the composites. Nowadays, because the aircraft is required like to create a lift force, we need a body lighter. 50 PhDs are completed, but out of 50, why I am mentioning that point is, the 25 to 30 PhDs are related to solve the society problems. That's very, very important, especially higher education students. Nowadays, one thing is, you have to understand your and save the village property. Village, I think everybody coming from different villages, you have to give something back to the village, not money or anything. If you see the village, a lot of natural resources are there. You should not spoil that. Nowadays people are occupying that rivers, whatever there in the nearby villages, even stadiums, small grounds are there, they are capturing. The people are not have a space to play games in villages. See, we have completed 75 years of independence, but till today we are in developing country. When we want to make a developed country, because these are all some of the problems. Every village. See, that's why what I want to say is, whatever we are doing here, it has to help the society. Why we have to help the society? You are getting a fees reimbursement. I am getting a salary from the government. These all money is a public money. From public money we are studying here and we are doing job here. It is our responsibility, it is our social responsibility to give return back to something to the society. Not money. Please try to understand. Giving means is not money. Try to keep in contact with them. Try to keep in touch with them. What are the problems they are facing? You represent the appropriate bodies. If the problem is solved, they will be happy. Money, these all are temporary things. When we are coming, we didn't bring anything. When we are leaving also, we don't take away. But what is the value addition you have given in your span of your life? Whether it is 70, 80 or 90. So that is very, very important. See, one of the computer science students, why I am giving this particular example is, now you know you very well the demand of computer science student nowadays because of job potential is there, lot of job potential. Even then he left that job, he came here and doing serving the society, and but he is getting profits also. That is a different scenario. So let us the game sports games when you are playing, the gadgets what we are using, here also the high stress regions at these joints. When you are playing, especially, we have number of methodologies we have studied. One part is you can do experimentation, bar or a beam, same. Now we can see here, what is the variation of the Young's modulus here? What variation it is? This equation. It is an exponential variation. From one end to other end, the Young's modulus is tremendously increasing because of this nano reinforcement. By incorporating a nanomaterial, continuously, see you are tuning the properties, the material properties is not at all same for the entire material. See that type of things you can create, non-homogeneity or aspect ratio, modulus ratio, you can continuously monitor, and such a material you can use different applications. Okay. Then with notch and without notch, also you can compare the 3-point bending or 2-point bending, etc. We can do UTM test or impact test, Charpy, isoid, etc. Now you see the material property, how the Young's modulus is changing with respect to aspect ratio. As you change the aspect ratio, the properties are changing. This is the peculiar thing which we are taking an advantage when we are using a nanomaterial. That is the simple terms what I want to say. Because of size dependent, as size means as you go on, as you are changing the size, the aspect ratio is changing. As you change the aspect ratio, the properties are tremendously changing. That is the advantage what we are taking. Whereas earlier if you take the homogeneous or isotropic material, same value for the entire material we are taking, which is constant almost. But that is not the case here. And that too, not a linear variation, it is an exponential variation. The continuously, the tremendous improvement is taking place, step by step. Suppose if you take a gold ornaments, you want to make a necklace or a chain or a choker or something else. To make that, what size of particle he is taking, mixing to create that much ductility. That is very, very important. That is where in ornaments also this technology, people nowadays using a lot of technology. So again, this is another aspect ratio, the properties, or you can do, just now I mentioned finite element analysis. You can discretize this. This is what we have done analytically by using your analytical equation. Now this can be done by using finite element analysis. Compare the values if experimentation is not possible. See, that is how you can use ANSYS, Nastran, ISA pattern. So many softwares are there nowadays in the market. We can use those techniques. I think you have studied, I think all of you, finite difference method, finite element method, finite volume method. Okay? First year only finite difference method you have studied. Finite element method, I think mechanical studied methodology, I don't know. Finite volume is nothing but a CFD. You can, these are the three tools. Lot of job potential is there in the market. Lot of jobs are there. Those are good, very good expertise in these three related areas. Then these are some of the joints where we are using by using functional engagement material like riveted joint, bolted joint, bezier joint, or solder joint, welded joint. If you don't do the joint, one important point you have to remember. You may not get improvement in all properties. Some properties may be improved, some properties penalty also may be there. But where they are good, we are recommending those applications. That's one thing you have to keep in mind. Because of that nano reinforcement, sometimes mechanical is improving, sometimes electronics is improving, sometimes electrical properties are improving, sometimes a combination, hybrid nature also there. Depend upon that, you have to suggest that this material can use for these applications. So that is where the beauty of these composites. These are different other applications. in especially defense mostly, airframes, rockets, brakes, jet vanes, and ceramic composites. Now you can see here, you can compare the composites. This is one of the Srikanth from one of the lab in Hyderabad. He has done a carbon-based composites. Carbon-based literature is very less as far as the composite is concerned. By adding ETPN, one of my students, ETPN has taken as a reinforcement related to carbon family, and a lot of citation we got that journal publication. Because very few people are doing research in this. This is where the carbon, E-glass, and the different materials. So the body shape is not important, especially if you can see Kedarnath, Badrinath, Jammu. This is the area where the material is transporting through mountains of, this is the transport mechanism we are using. No aircrafts, no locomotives, no automobiles. Only whatever the material we are transporting this. Even if you see the size of animal, how much load it is carrying. You can see the size of a human being, how much load he is carrying. You can compare with a sports person, how that is very, very important. Not the strength is, what is the strength you have in your body. Your bone strength, your physical strength, and your mental strength also. Very, very important. If these three are coinciding, if you concentrate on your target, definitely you will reach. See, that is where these materials you can tune it. These are some of the carbon applications, aerospace and defense applications. Armored vehicles, we are using this nano application. Here we have to use, and this is where now the last topic, another systems. When nano we are talking about atoms, molecules, unit cell. When micro you are talking about grains and grain boundaries, etc. Like your grain size, Hall pitch equation, how the grain size is changing, that you have to calculate. The different parameters like nanoscience, nanotechnology, nanomaterial, nanocrystalline. Your topic is nanostructured material synthesis and characterization. See, this is where you see the 1 centimeter cube, you divide into 0.5, the doubled almost area. If you further divide 0.01, 600 centimeters square. See, even if you can further divide into, you will get something like 24 times. If you repeat that its size, you will get almost like a football stadium size or a cricket stadium size. That is what the surface area tremendously improving. That is one advantage which we are using. The important when you are taking a bulk and nano. Bulk material size the independence. That I already at the starting of the class I mentioned. Whereas the nano is size dependent. The grain size is one of the important to give the material whether it's a bulk or a nano, that you can decide. Because of bulk to nano, bulk there is no much difference, but in nano if you take 10 nanometers the properties are different, but the important point is you may not expect unusual, unexpected, exotic and spectacular properties are coming. For some of the examples, solid turns into liquid at room temperature. Brittle material behaves as ductile, inert material becomes highly reactive, stable material tunable, magnetic materials non-magnetic. These are some of the peculiar properties you will get. Insulators become conductors. See, because of these advantages, we are using the three things. These are the thumb rules, please all of you. One is surface to volume ratio tremendously increasing. The second is quantum effect, that is what is the field emission, which we are using in SEM, TEM. Third is critical length, that is the aspect ratio. These are the three parameters. Because of this technology is the tremendously which we are using. That's what I mentioned, what is the difference between macro, micro, nano. If you see the nano machine, that is a gauge for power transmission. In this 15,342 atoms are there to transfer the power from one shaft to the other shaft by a reduction gate. Simple gate train, compound gate train or epicyclic gate train. Anything you can use. But see how many atoms in that particular. See again different tubes, wires, pipes, bearings you can make it. This is one thing where solar If anybody just now given a battery in your shirt or sarees for ladies, you put this type of solar cell. This is a solar cell. You put inside your fabric when you are moving or when you are sitting or when you are, you can get a lot of energy. Because most of the wars you have seen because of this fuel, petrol, diesel, this crude oil, most of the World War I, World War II and other. Nowadays even Ukraine also little bit linked with that. Now that is where you can go for alternative energies. That is where the solar energy, you know very well, our country is very good in that particular aspect. Some of the Western European countries, they don't have so many days with the hot sun. We have that advantage, that energy can be saved. I think recently, I hope I am if you following in Visakhapatnam, one of the hotel is constructed with the solar panels. To join Army, Navy and Air Force. But here that rule is not there. They are only allowed to higher education. But in our country it is not there. But you don't underestimate that. Because always our neighbors are Pakistan or China, always ready to make any attempt. We should be very cautious about that. See, that's all from my side. Thank you very much. Now if any questions are there, we will spend some time.